Good afternoon to one and all. Today's topic is searching. Let me wait for 2 more minutes, or can I start it? Yes. Today's topic, I'm just starting it. Today's topic is searching. I'll just increase the font of the content. Yes. Searching means finding. Finding whether the required thing is present in the stuff or not. It depends upon the input what you are searching and how much huge amount data you want to search in it. Okay. Here we are having different types of search. So depending upon the method, it is defined by its name. So the first searching technique is sequential search, which is a traditional technique to find an element in a collection of elements. That means in a list of elements, I just want to find an element which is present in that or not. So in turn, it can also be called as linear search. And it is a very simple and basic algorithm. We just want only the list of elements first to be as an input. Then one searching element as by name item. I'll compare this item with each and every element in the list until I reach the end of the list. Right? From 0th location to n-1, I'll keep on repeating the value. Suppose the element is found, then I'll return its particular position that at that place so and so element is present. Suppose if it does not find any match with it, I'll just return that the element is not present. Right? So it is a very traditional technique which is used to find an element in a collection of elements. Mainly it is used to find whether the element is present in the list or not. Right? And once you find the element, it will just return the location at which position the element is present. Right? Then the next searching algorithm is jump search. Jump search. What is meant by jump? Skipping something and then going to it. That is known as your jump search. So in turn, please look at the playlist of your favorite song, seeking through a catalog to pick to the next meal. That means, suppose in a cassette, there are 6 songs to be recorded upon it in your tape recorder, in your one cassette. Suppose you like frequently the third one. That means you are skipping the first and 2. You are jumping it to the third one. Suppose in a menu card, there are so many starters, meals, types and all. But you won't make the first one, no? It is your wish. You want to go to whichever thing you are willing to have it. So it is quite in that same way, the computer will perform the searching element in a collection of data or a structure in such a way that it carries some number of data sets to be skipped, then something to be searched. So how to get skipped that one, that is known as your jump search. And it is also known as the block search also. Jump search can also be called as block search. In this particular algorithm, we are going to return the location of the target element from the sorted collection. And remember one prior condition that in the sequential search, the list might be either of the way. Either it can be sorted or unsorted. Whereas in the jump search, the list should be up compulsorily in the sorted order. The major point here we need to remember is For this example, the list should be in the sorted order. That means we don't go sequentially. We'll just skip some blocks and we'll consider the other things. So how to skip that? That we are going to evaluate in the sorted array. So the element with the highest value in each block, value less than the smaller, will be the target element. Next element will be the greater element. Like that, the list will be, if the element is less, it will move to the left part. If the element is greater, it will move to the right part. The other name for it is binary search. In this particular algorithm, what we are going to find means, for the sorted list, we are going to perform the searching technique. How we are going to do that means, by looking at this example, you can understand it in a better way, right? So here is one example of some integers in the ascending order, and we are looking to find the value 55. We are looking to find the value 55. This binary search maintains some subsequence of the starting sequence and the target value is surely located. And this is called search space. Search space is initially entire sequence. At each step, the algorithm compares with the median value in the search space of the target value. Based on the comparison, because of the sequence is sorted, it can eliminate half of the search space. By doing this repeatedly, it can eventually lift me the search space consisting into the single element or your target element. As we are interested in the location of the target value in the sequence, so we will present the search space also. So also it indicates the indices of the value where it has to be present. The only thing what we are supposed to remember in this binary search means, if the element is less means we are going to search it in the left part. If the element is greater means we are going to search it on the right part. Smaller the value, the target is the left part. Bigger the value, the target is on the right part. Okay. So look at this example. Here we go with this example. And in the similar fashion, I'll just calculate the middle element first. It is 72. My 55 is less than the 72. So I'll pick only the left list. I'll skip the right part of it because greater elements I'm not interested. As it is in the sorted list, I'll concentrate only upon the left part of it. So what are the elements present in it? 55 and 68. Now, again I'll calculate the middle position. Again, I'll just verify whether the element is equal with the mid or not. Yes, in this situation, it is equal. So I'll come out of the list and I'll tell that 55 is present in so and so location. Right? This is what the implementation of your binary search. And in turn, which will reduce the search space for you. Okay? This is what the implementation of it. So, please look at the example code. Here is the first step. Starting index is 0 and ending index is 8. Mid index is 0 plus 8 by 2, that is 4. So A of mid will be compared with the searching element 23. If they are equal, then I'll tell that element is present in so and so position. In this situation, they are not equal and the searching element is greater than the mid. So I'll be looking into the right part of the list. That means I'll be moving it to the mid plus 1 to the last. Right? Like this, the search continues for the next iteration also. This is what the binary search. Always remember, by the name itself, it's suggesting that for each iteration, we are going to shift the list into two parts. Based upon the element condition, either we are going to the left side or we are moving it to the right side. Got it? Can I go to the next search? The next searching technique is Interpolation Search. What is this interpolation search means? It is used to get different approach for the time complexity and to make the searching algorithm easy. That means it is a combination of your linear search followed with the binary search. So how this will get implemented means, in the linear search only, we are going to continue the binary search also. That means first we'll take the list in terms of your sequential order. Then we are performing the binary search, that is dividing the list into two halves based upon the condition. Next, we will concentrate upon the next search, that is Fibonacci search. You all remember the Fibonacci series. 0, 1 are the first two elements. In order to achieve the third element, it's a combination of the preceding two elements addition. So how this search will be continued means, it is used by the method called divide and conquer algorithm that narrow down the possible location with the add of your Fibonacci numbers. Compared to the binary search, where the sorted array is divided into two equal parts, one of which is examined further. Fibonacci search divides the array into two parts that have sizes that are consecutive Fibonacci numbers. So Fibonacci search divides the list into two halves based upon your Fibonacci numbers. On average, this leads to about 4% more comparisons than your executed ones. So why don't we just analyze it in a simple part and click it on a good effective method to calculate the searching element in the best and average cases. It would be big of log n. So overall, what is the final intention of this is, the final intention here is we are having a combination of binary search followed with the Fibonacci series division, right? And here is the property that defines the numbers in the sum of two precedences. And therefore, the sequence to be computed by repeating addition, then the consecutive numbers equal will be a ununiform or non-uniform memory storage. So your Fibonacci series is generated by using the storage location depending upon the location assigned to it. So time needed to access the storage location varies depending upon the different time complexity for it. So CPU will be giving certain amount of time period to achieve the powers to it. So in turn, it has no longer trend off to the comparison based upon your search algorithm that is queued similar to the Fibonacci search. So Fibonacci search is derived from the golden section search, an algorithm by Jack Kessler to search the maximum or minimum on unconditional function by an interval. So here is the method to define that interval and to define the method for you. So here is it, algorithm. Let K would be defined as a element in F. The array of the Fibonacci series will be n equal to Fm. Is the array size. N is the array size and Fm is the smallest element in the F, and that is greater than the n. The array of the Fibonacci numbers is defined like this. F of k plus 2. That means third element will be the addition of the first two elements. K plus 1 will give you the k plus 2. where f of 0 and f of 1 will be 0 and 1. To test whether the list ordered numbers are here satisfying the property or not, we should analyze it. So here is the method K. If it is initially 0, we'll stop it. Or not, we'll compare it. And if the item got matches, we'll be stopping it. If the item is less than the fk minus 1, decided to declare the element from the position and return to the step 2. If the element is greater than that, design to define it to so and so and again return to the step 2. Alternative implementation by this is calculating its position and implementing it. Right? This is what the another terminology used to search by using the interpolation search. So initially we are having this particular values as your input to your algorithm to the consecutive Fibonacci numbers. Please compare k less than k of I. Go to the step 3. If k greater than k of I, please go to the step number 4. And if k equal to k1, the algorithm terminates successfully. That means if it is less, it is performing something. If it is greater, it will perform something. If it is equal, it will return successfully that element is present at so and so position. So in the step 3, if q equal to 0, the algorithm terminates unsuccessfully. That means the element is not present. Otherwise, set the PQ to such a value that I minus Q, P minus Q, which will move P and Q one position back in the Fibonacci series. That will return back again to the step 2. If it is less, again I should move back to compare with the previous values. If it is greater, I have to move forward 2 positions to check the next values in the list. Like that, the process continues. If the value gets to 0, that means the element is not present, we'll quit the algorithm. Then if the 2 variants in the algorithm presented above always divide the current interval into larger and smaller subintervals, the original algorithm, however, would divide the new interval into a smaller and a larger subinterval. This is an advantage that the new closer to the eye suitably circulating such a magnetic tape. So based upon that, you are going to continue it. Okay. So depending upon the particular scenario, we'll be performing whether we continue it or we quit from the algorithm based upon this internal leads or internal numbers, right? Exponential search is Exponential search is the next method. What will concentrate upon the further topic. Exponential search is a combination of 2 methods. Find the range in which the element exists. Perform a binary search in that range. First, we need to find the range in which the element is present. Then we need to perform the binary search. Binary search means dividing the list into 2 halves. If the element is less, we are going to concentrate on the left part of your searching or divided list, or else we'll continue with the right part of it. So let us look into this exponential search in detail. So here is the exponential search. To begin a search, we find the range. So we do this by first checking to see if the desired element is in the first position or not. If not, we try an array size of 2. Then we'll go 4, then 6 and so on. Just it's an increment of your even number. And if the last element in the partial array is not greater than the element, we perform a binary search. Think of the binary search as a chopping of the array. First, we look at the whole array, then chop it into half. That means split it into two halves. If the value is less than the middle, we look at the lower half. If the value is greater than the middle, we look at the upper half. This is repeated until we find the element or the list is empty. This is what the thing will be performing in the exponential search. So in order to find an element, whether it is there in the list or not, we need to find the range in which the element is present and then perform the binary search, right? So here note a point that in order to do this work, we must arrange the array in the sorted order. That is what the prerequisite for your binary search. So here, first lines of code, check to see whether we get element in the first element or not. Next, we set the counter to the loop, that the array to set the range. The logic of the while loop will go on like this. Is I less than the size of the array? And if the current element less than or equal to the search element? If yes, multiply I by 2. That means double the size of your range, what you are picking it. If not, please perform the binary search, whatever the list you have taken. When the loop starts, I is 1, then 2, then 4, and so on. When it becomes 64, we know that the element somewhere between I by 2 and I, since there was not a greater value in the list iteration, after the while loop exists, we can use the powerful tool provided to us in the existing Java library. In the code above, recall that we have imported java.util.library. This includes the support of array processing, which would be binary search method in the array class. That means it's already executes the code in it, just we are utilizing it for our purpose. Returns the array which is having the maximum position where the element is present, right? So here is the method in detail. First, we take the code which will run upon your binary search or jump search, whatever you want to build upon it, which will return the value index, whether it is present or not. So first look at the jump search code. Initially, we need to import java.util and the class name is jump. Then jump search, what we are performing, a math floor to calculate the square root to present the step and just calculate the minimum for it, comparing it with the previous search. Then we are performing the linear search to accompany it. And after retrieving it from the main function, we are passing the array elements and the searching element and then calling the jump search. Depending upon the requirement of your element position, it will return the value for you, right? Okay, here is the binary search. Binary search logic where the list should be in the sorted order. Where the list will be in the sorted order. Yes. Here is the logic for the binary search. So at the index, we are just performing what is the array element name and array source and all. And whenever it will be compared with the middle element, first we'll calculate the middle position. And if the element is compared with the middle, then we'll return, if it is equal, then we'll return the middle position. If not, we'll be checking whether it is less or greater. If it is less, we'll return the, we'll continue the process with the left part of it. If it is greater, we are continuing the process with the right part of the list. Like that, we are performing the binary search. So here is the output for it. Suppose I just want to search 18 with the input array which I have given. Then element is present in the so-and-so location. This is what the code for it. Fibonacci series code. If you find any difficulty, please try to ask it and get clear about the logic, because they are the lengthy logic, exponential logic. These are the assignment questions. You need to implement the program for the sequential search. That is the program for your linear search indirectly. Here is the program to implement the interpolation search. This is the assignment question to you, which I have already discussed in your theory. Please try to accomplish it and finish the task as early as possible. Okay. This is what the exponential search. Tomorrow I'll continue with the graphs. Do you have any doubts over here? Are you having any doubts in this? So these are the searching techniques. What we have learned up till now. We have learned 4 different searching techniques. That is sequential search, jump search, binary search, interpolation search, and exponential search. So based upon all these 5 searching names, 5 different programs you are supposed to sort it out and try to learn them. Okay. So your Fibonacci search is important, followed with the binary search. Try to analyze this with different examples and complete the assignment. for your lab external exam. Okay? Any doubts? So I'm repeating all the algorithm once again. Linear search means the flow will go one after the other, or the sequentially the search will continue without skipping any elements. Right? So method will be continuing each and every element. Jump search means it will skip certain elements by seeking a catalog position. That means by moving a bit faster when compared with the sequential search. This jump search is also called as block search, right? Then in the binary search, internet can be called as a binary search. In this particular searching technique, we can find the elements very quickly when compared with the linear search. But the condition what we prefer for this binary search is the list should be in the sorted order. That then only we will call the list in the searching. So it is very clear that the list should be in the sorted order, and your searching space will be reduced to half of it because we are checking the element implementation with the binary search. This is what the implementation of your binary search. Remember the logic? Please look at the logic once. Dividing the list into two halves, comparing with that element first, middle element. If it is equal, returning. If it is not equal, then performing the condition or checking the condition that element less than the left or not. Like that, it will be continuing. If not, it will just move to the left side or right side, depending upon the condition. If it is less, it will move towards the left. If it is greater, it will move towards the right side. This is what the procedure generally we follow for the binary search. So interpolation search means it is a combination of your linear search strategy followed in the binary search. That means first we'll consider some list. For that list, we are going to take the combination of it. So in turn, it is a major problem where we get rid of some different basics of time complexities, but we do work with both sorted arrays and finding the middle element repeatedly. So the time complexity will be big of log n only. Right? It is only big of log n. Then coming back to the Fibonacci search. Fibonacci search is a method used by the Fibonacci numbers. What is Fibonacci numbers? 0, 1. In order to achieve the third element, addition of the previous two elements. Always remember, in order to fetch the next element in the Fibonacci series, it is an addition of the previous two elements. So 0 plus 1, 1. Then 1 plus 1, 2. 2 plus 1, 3. 3 plus 2, 5. Like that. Fibonacci series will be maintained. By this Fibonacci series strategy, we are going to find the searching element. So how that will be done, we'll see with this example. Okay. Try to maintain the searching strategy in terms of your average, best and worst cases. Remember, the best case means finding the element in the first instance itself. In that situation, the time complexity will be always big of 1 only. Whereas average case or worst case means we may find the element somewhere in the list or we may not find it by the end of the list. Somewhere in the middle, it could be like average. We may not find it at the end or we may find it at the end. Not finding at the end will lead to the worst case. So what is average and worst case? Somewhere in the middle, if we are able to find, that means after certain number of iterations, if we are able to find, that would be an average case, time complexity will be there. So finally, by this Fibonacci search, we are going to evaluate the element by using the Fibonacci series indexes and continue the process until we find the element. This is what the general scenario what we will be following. So the time complexity for it in the average case would be big of log n, and in the worst case also it is big of log n. Okay, please do remember the time complexities of all the algorithms for your exam point of view. Okay. Seek time means how much time it is taking you to find the result. That is seek time. This is about your searching techniques, right? Here are the some of the algorithms or codes what we are supposed to perform upon it. So try to analyze it and get the flexibility upon it. Okay. In tomorrow's class, I'll continue with the graphs concept. So I'm ending for today. Any doubts is there? Please message me. Here are the searching methods which are there in your syllabus. Please learn the logics of all the algorithms and finish the assignment questions. Try to execute them. Remember that you are going to save your all files in .java extension because you are implementing with the .java software, right? In order to compile the code, you need to use the command javac space filename.java. Then in order to run it after getting free from the errors, java space filename, which will fetch you the output on your screen. Okay. Am I audible? Am I audible? Am I audible? So please do remember all these methods of searching. So here is the method to be implemented for the searching techniques. Today I am closing the class. Tomorrow at sharp 3 o'clock, I'll be starting the graphs concept. That is the last topic in your syllabus. Please do listen to the topic and read the theory. It will be comfortable for you. Right? Okay. You can leave, ma.